So, hello everybody.
Hello.
I will be talking to you today about rootkits, specifically inline function hooking and trampolining rootkits. This is going to be a motivational sermon to get you all hyped about CPTC this weekend. So we are 2 of 3.5 of the devs of the Buddhism suite, which is a Linux persistence suite that we're developing for the Red team. This is part 1 of 3 of that suite. Rayne, go ahead and introduce yourself.
So I'm Rayne. I'm a senior. If you guys don't know me, I'll be graduating in December, unfortunately. But I've done a lot of different. Yeah, I should probably take the mic. I've done quite a few different competitions. I've been on the blue team. I've been on the white team, and I do a lot of work for the red team. That's what the rootkit's for. My other hobbies: play the drums, and occasionally I play some Counter-Strike. Nobody seems to play that game anymore, but whatever.
I'm Hulto. I do blue team, black team, red team. I build persistence mechanisms for Linux so that you guys can't kick us out of your box during blue team competitions. I graduate sometime. I think Counter-Strike is stupid, Rayne, because Minecraft is better. And then Nick, who is currently at BlizzCon, is also a part of this. Yeah.
Does he even play any Blizzard-based games?
No.
Not anymore. he used to, but he's just kind of chilling there now. He could be watching the stream right now. I don't know.
We love you, Nick.
He wanted to make sure that we included that he's a socialist. So, yeah.
Very important.
Anyway.
What are we even talking about? We're going to cover some general rootkit stuff, like what they do and like kind of get into the nitty-gritty. Last time, I gave you a real quick like action book adventure, something that you can, give to your mom and like, hey mom, this is what a rootkit is. We're gonna go a little more in depth here. So if you get lost, let me know. And you can always find me afterwards and ask me more questions. After you, Rayne.
All right, so what is a rootkit? There's this kind of interesting definition that I stole from veracode.com on the slide. I'm not going to read it, but basically what it says is that a rootkit is supposed to hide whatever it is that you're doing on a box and give you deep level persistence. I think this definition is a little bit goofy, but it is very succinct.
It's clandestine, guys. It's clandestine.
Jack didn't like it very much. Anyway.
Whoa, what is that QR code?
What QR code? I don't know what you're talking about. Why write a rootkit? What's the point even? Why would you spend time writing in C and assembly and building this silly thing? For fun. For the lulz. Other than that, like red team persistence, once you have this, you're kind of in. It's very hard to get rid of, especially ours. But yeah, that's about it.
No, you didn't. Simon was just claiming he got rid of our
Fake
rootkit.
news,
Yeah.
Simon. Fake news.
Yep, that was actually your fault, Jack. But anyway, so rootkits, typically when you're talking about a rootkit, the features that it's going to have, it's going to be able to hide files from the user or from standard users, unless you're a special red teamer, or hide processes, hide network connections, all the things that you see on the board, allow you to privesc. But our rootkit, we are more in this experimental capabilities kind of, I guess, list where we are trying to add things like preventing people from removing the rootkit in any way, shape, or form. We are attempting to do something called port sharing, which is kind of neat. Reverse shells, all that kind of stuff. So rootkits are, you can pretty much do whatever you want with a rootkit, depending on how deep you go and how many functions you hook. But
Yeah, for those who don't know, if you have a rootkit, you are the kernel, which means you are their computer, which means that they're using you to do what they want, so you do what you want. So I'm going to talk to you a little bit about how it actually does those things. Last time I gave a printer example of like, oh yeah, this is something you could do. Like, you can change the words that you don't like. Here's how you actually do it. For file hiding, you're hooking git dents. That's the git directory entries, and you're just removing all of the files that you want to hide. So git dents goes and it says, here's all the files in this directory, and then it returns it. Our thing says, okay, I got all the files. That's my file. That's not going to be in the results. removes it, copies everything else into the result, returns the result. That's how you do file hiding. Process hiding, same thing. You just hide the process ID number instead of the file name, and you make sure that you're in the PID directory, the proc directory, because otherwise you're going to be hiding random 5-digit number folders and files all over their system, and that would be pretty funny. For privilege escalation, you're just setting their ID to 0, which is root. So all processes have an ID, like a process. So there's like the process ID. It's not what we're touching. You have the user ID and the group ID. You set those to 0, you're root now. As the kernel, we can do that. For hiding itself, there's just like a linked list of kernel modules that are loaded. You just kind of take yourself out, fix the linked list, and you don't exist.
Yep.
What's a barn?
It's a motivational sermon, sir. We want you to think about all the motivation here. Look at this red barn. This red barn could be yours if you can get rid of our rootkit.
So one thing I just wanted to add about that last slide, there are other ways to do these things. So like, for instance, most of the rootkits that you're going to find on GitHub, written for Linux anyway, that hide processes, hook the getDense system call in order to hide the processes. There are other ways to do it, which are sneakier and...
Well, don't tell them those.
I'm not going to tell them those. I'm just saying they do exist. So you can look for them. And sometimes, like, there are ways to detect rootkits that getDense makes a little bit easier, but hooking different system calls makes it a little bit harder. So.
All right, stop telling them things.
Just saying.
So that was kind of generic rootkits. Now we're going to tell you about goofkit/yin, which is our rootkit that we know and love, and you will all learn to love if you go to UB, RITSEC, or UB again. So ours is better because we do inline function hooking and trampolining. So the standard way, if you guys remember, is you overwrite the system call table. So like syswrite gets redirected, you rewrite the address of where syswrite sits to be evil syswrite. So instead of doing that, we don't overwrite the actual table. We follow the table along, we look at where the instructions actually are, and we overwrite the instructions. So we're rewriting system calls by hand. It's really fun.
I think we have a good graphic for that on the next slide.
We do. So that's the inline function hooking. Trampolining now is we have control flow, we've overwritten the instructions, we jump to our code, but now we want to be able to still execute the regular system call. Because remember beforehand, we got the list of entries and we went back through and we removed the ones we want. We still want to get the original functionality so that we can modify the result. So what we do is we trampoline. So the first time we execute, we go to our evil function over here, and we get the results by jumping to the original code that we overwrote, executing that, executing all the code after our hook, and then returning up to our thing, and then we can remove everything. There's a good graphic, I promise. So standard, everything's normal. We haven't rewritten anything. Regular hooking, we're overwriting the system call pointer. So syswrite points to evil write. And then we can still call regular write because we saved the address of it. So we just call this regular write. Back to simple. Nothing's happened here. This is normal. This is how it should look. And then inline hooking with trampolining. So we didn't overwrite the system call table. Syswrite still points to syswrite. But write now has a jump to evil write. So we execute write. We go over here. We've copied out the original code. We're executing our malicious hook, this red stuff here. We jump over to evil write, and then we can call the original write using our trampoline because we've saved the original code. So we execute that, everything else, and now we have original, and we control it. You can do inline hooking without trampolining, but it involves writing and unwriting the system call frequently every time you want to use the original.
Can you do that so that the syscall table looks the same?
Yes, so by doing this, the syscall table looks the same, so you can't just do baselining based off the system call table. Also, it is a little better because if you're trying to like pause all functionality, you can just say, okay, we're going to pass everything through, so I don't rewrite anything. Whereas in a regular rootkit with like the system call hooking, to pause, what you would be doing is you would be reverting the table. So this way, we just have a pass through because the code flow execution just looks like our jump, our code, their code, their code, in paused. In normal, it's evil jump, our code, calls their code, and then manipulates their code and returns. Or manipulates their return and returns our stuff. Does that make sense? I said return a lot in that sentence. Okay.
There's one other thing that we should point out about inline function hooking. The other major benefit to it is it allows you to hook functions in the kernel that are not system calls. So it gives you pretty much access to anything that resides in kernel space. So you can hook things like netfilter, for instance, which is the Linux kernel module that allows you to use firewalls or not, or do networking in general or not. So, you know.
Oh, hey, Simon.
So with this method, you're like inserting that jump to the original write function, correct?
Yes, that is correct. We are inserting the jump into the original write.
So how do you go about inserting that function right now? Where are you
So
rewriting right?
we are not completely. We rewrite the first like 12 to 15 bytes of write.
So how do you do that without breaking? Like how does that work?
Very carefully. So in my code, I have some shell code that I wrote out. So it's got like your \x whatever to do jump, then an opslet at the end to even things out. The most important thing is don't cut instructions in half, because instructions can be variable length in x86-64. So when we're going through, right now we do it by hand, and we're hoping, Scott Court, where are you at? Scott Court is going to be building an LDE so that we can just do this automatically. But right now what we do is we go in, we print out the first like 20 or 30 instructions. We take our jump, we put it next to it, and we say, okay, are we going to cut an instruction in half? If so, we pad out to the end of that instruction, which is where that variability between 12 and 15 bytes comes in. So we pad it out. Then, once we have our hook, our jump, right here, once we have that set, we copy their code, that same amount, the same length, we copy it, we save it in a buffer, we write our code to there. So now we have the evil jump inserted, the hook's inserted, and it points to our code, our malicious function. Then we execute our malicious function. At the end of our malicious function, we just jump to that buffer that we saved. That executes. We have a little jump at the end that jumps back to the length plus 1. So we're jumping to right after our hook. Great question.
Something important to point out, he mentioned an LDE. What that is a length disassembly engine that will like automatically calculate the length of the instructions so that we can figure out where they end so we don't cut them in half, is basically the point of that. So, anyway.
My
Yeah.
emoji didn't show up. Oh.
Oh, wow. Yeah, he did have a
So what can you do
Facebook-esque
about
emoji.
it? We're not going to tell you. It's your job. Yeah, reinstall your operating system.
There are things that you can do to get rid of rootkits. We're not going to share them with you, though. It's a good exercise for all of you blue teamers.
Yeah.
Theoretically, well, maybe not ours, but in general, a lot of rootkits can be.
So just quick recap. Rootkits are cool. They're hard to remove. They can do a lot. And throw some love to Red Team. Generally, we don't use it. We don't have to. We have a lot of other persistence. It's usually oh wow, they locked us out. All right, we're gonna use the rootkit. But yeah. Any questions? Mr. Joe Graham.
How long did this take you to write?
So last year I started on this project. It took me about 3 months to do the inline function hooking and trampolining, which is like this weird blob of code. If you want to go look at it, it's just like create trampoline. And it's just
Kinda, sorta. It took a lot of passes.
When
for
I
me to
heard
understand
when
it.
I heard that other people were going to work on this, I went through and I commented. He still spent about 6 hours trying to figure out what it all meant. So, yeah, if you're interested, you can check it out, and I'm happy to explain it or try to explain it. I kind of forgot what each section did because that was last year, and I've been working on everything else that the rootkit has to do. So, yeah. Hey, Simon.
What's your biggest advice?
Biggest piece of advice for people who want to write a rootkit.
Read a fuck ton of them.
In your VM, when you're using VMs to build this, because you shouldn't build it on bare metal, because don't do that. Advice 1, don't build on bare metal. 2, use a VM. 3, use snapshots. It's a lot faster than restarting your box when you crash, because you're going to crash a lot.
Yeah. Also, make sure that until you are sure that your rootkit is like stable and functional, don't add any kind of reboot persistence. Because in case you do, in case you do forget to snapshot, you can reboot and the kernel module will be on. Well, this in particular is a Linux kernel module rootkit. There are other kinds of rootkits, but when you're dealing with kernel modules in kernel space, then you need to. If you reboot, it will not be loaded in unless you have some kind of persistence that is loading it in. Don't do that though unless it's stable.
Also,
But
don't put an ISTS.
an ISTS.
Very good. Yes, don't deploy at ISTS unless you know it works. Joe Graham.
Did you get anything out of this besides just the cool thing that allowed you to own all the rules?
Yes, I got to brush up a lot on my Linux system internals, so I learned a lot about the kernel and kernel modules and assembly in the kernel and how bad it is to take things from the kernel and try and copy them to user space.
Yeah, that's a bitch. Yeah, in general, you're going to learn a lot about Linux kernel development as well. You can actually develop things. I know in security this is kind of like an abstract concept, but you can develop things for the kernel that are not malicious. And I would actually have an idea of how to do that if I really wanted to. You're not necessarily hooking everything in the kernel like you are with a rootkit, but you do learn a lot. So it is really a great experience.
It's also a really good thought exercise because you're like, wow, everything I'm doing can be hooked in so many different places, not just in the kernel. Well, there's a lot of places in the kernel, but not just in the kernel, but everywhere between here and the kernel, there's so many places they could hook everything. And it really convinces you that the best way to secure your box is just to reinstall.
Yeah.
Simon.
So how difficult is it from older versions
So ASLR is not really a factor because we're not exploiting anything. We're just loading.
Incorrect.
Was that-
So
we do
there
have to
is
disable it. I forgot about it.
KASLR,
Yeah,
which
that's
is
different,
the
though.
kernel address space.
It's different.
Yeah, and yes, it does. And yes, it is really annoying. So we turn it off.
So that's why I was saying it's not really a factor. In the kernel, you have access to everything. So you can just turn it off, disable write protect, do whatever you want, and then enable write protect again. That's pretty much all you do. So there are macros that you can find that do that. You can do whatever you want. You are ring 0. Yeah. You have the ability to execute any kernel functions, including disabling and enabling ASLR if you really wanted to. Whatever.
Well, I do it as root in userland because it's much easier. But yeah, you could. There's a lot of things you can do. Any other questions? These are good questions. I like them. All right, cool. Well, thank you all for listening to us. If you guys have questions afterwards, come up to me or Rayne or talk to Nick when he gets back from his gaming conference. You can ask him what video games he plays or doesn't play.
The answer is none. Yeah. Anyway. Thank you, guys.